Today we're going to talk about MongoDB, which is the database where we're going to persist all the data within and retrieve the data from. So MongoDB is a NoSQL database, NoSQL, which means we're not going to use SQL to persist or retrieve any data. We don't need this special language. Instead, we have methods that we are going to call to persist data and retrieve data. A NoSQL database has multiple types, like vector, graph, column, and one of the types is document-based. And MongoDB is a document-based NoSQL database. What we save is documents. So if we want to type like this is created for performance. Performance, perf, and scalability. We will talk about scalability in details after tomorrow on Wednesday. Today we will understand why this kind of databases are performant and why they are preferred to be used for big data. Because we can persist data so fast and read data so fast. Now, what does document level mean? So we have a database. In SQL, we have something called table. We don't have like the concept of structured table. What we have in NoSQL is some sort like a bucket. This bucket we call collection. So every single time you see me saying collection, all I mean is a table. But while the table is structured, so you have to create the table and you set every single field name and data type. You say, I have a name field and the type is string. You can't store another column called age if age was not created. And the value of name must always be string. You can't save another different data type. So that's for the table. In a collection, that's not the case. In a collection, you create some sort of bucket where you save objects. And this object can vary in property names and value types. There are no rules. However, at the end of this lecture, you will see that we are going to set some sort of structure for all the documents and data types using a wrapper called Mongoose. So a feature of NoSQL databases that they are schemaless. There is no restrictions for a schema, just like what we do in structured SQL databases. Another thing that you will see me talking about is the data itself. So here the data, we call it row, right? Every single row represents new data. And here, every single object, we call it documents. As I mentioned before, they are document-based. So the object that we save inside the collection is called document. And documents are saved in BSON. And BSON is binary JSON. Why we use binary JSON to persist the data? The reason is BSON provide me with extra data types that do not exist naturally in JavaScript. Now we have data types like big numbers. Now we have data types like dates. JSON doesn't have date data type. Another data type that we get with BSON is something called object ID. And an object ID is a new data type that provides always a unique value every single time you want to create a new object ID. So we use this for identification for every single document. Now, every single document as well has two conditions. The first condition is it must have underscore ID field, and underscore ID field should be always unique. For that reason, we tend to choose this data type for the underscore ID, but you may choose a string or number or anything, but you have to take care of generating a unique value every time. Or pick the convenient type object ID to be the default data type for the underscore ID field. So every single document must have underscore ID, which is always unique. Second rule is the size of the document, the size of every single object should not exceed 16 megabytes, which is a huge size for a single row in a database. We never save more data in a single row more than 16 megabytes. So these are the two rules that we have for every single document. Any questions so far? Can I wait a little bit more? Okay, no question. So I talked about an important feature, which is performance. Why NoSQL databases are more performant than SQL databases? So with SQL databases, we have relationships between multiple tables. So SQL, NoSQL. In SQL, we create table 1, table 2, table 3, and we tend to have relationships. Primary, foreign, primary key, foreign key, and we set some sort of relations. And when we try to write the data, we need to write the data in 3 different places and maintain references. And every single time we want to read the data, we need to read the data from 3 different places, aggregate the data before we send it out. So as you can see, read and write is considered slow. This is why they are not meant for big data, where you need to read and write the data really fast. And the reason is structure and the checks. So every single data you want to write data, for example, you don't need only to write it in 3 different places and maintain references, but also you need to check the constraints that do I have a field called name? Yes. Is the value is really string or am I sending different? So you have also to data check every single piece of data. This is why the read and write is slow. In NoSQL, we like to design the structure of our data in a way in single place, in a single collection, because we don't have native relationships. So we put all our data in a single collection inside an object we call documents. Since there are no rules or checks, constraints for what kind of structure inside this document could be, I can read the data from one place immediately. I can write the data, dump it in a single document, and I'm done. So read and write is really fast. And that's why they are more performant. But if you choose to design your data in multiple collections and have a primary key and foreign key, and you maintain readability and writability to 2 different places, then you're doing something really bad, because these databases aren't meant for this purpose. It's better that you go back to an SQL database and use these databases for that reason. So if I have an example where I have username and full name and email and password, I use this collection to sign up and log in. But now what if I have here, for example, a books collection, and you need to write inside books the author name, and the author is the user. So do you save the user ID? Of course not. If I do save the user ID as a reference to an underscore ID here, then I created kind of a relationship. And now whenever I want to read or write, I'm going to read and write from two different places. So what we do instead is to repeat the data. We do mention the user ID, the full name, the author email as well. So we save them all as part of the author property of this object. This way, when I read the book or write the book, I have it read and write from a single place, and I don't need to read from two different places. Any questions so far?
Sir, I have a question.
Yes.
So related to the NoSQL. So is fast or not fast? It depends on the document structure, right? Example, I have one query, and my query, the data store on the two collection. So it means that in the document structure, I need to define how we can get the data from two queries. So
It's
my
going to be
question is,
slower. So yeah, you will need to perform two queries because, for example, what we can do here in single query, here you need to do it in multiple queries. That's why it's not a good design if you put your data with relationships, because there are no relationships in the database. So you better design it with repeating the data in multiple places to read and write from a single place, and that's best.
Good morning, Professor.
And I understand that, yeah, before you asked me the question, and I understand probably concerns about, hey, what about the data when it repeats and you need to take it, then you have to update it in multiple places, and that's okay. Yes, questions?
Thank you. You just answered my question because like
Yeah.
I wanted to know what would happen like if I want to update like for example like the data of the user, and then like the same data is repeated in multiple collections. So what should I do? Like you just said,
Yeah, you need
I have to
you need to take care of
update it.
updating the data in multiple places. The update will be asynchronous and in batches, so no worries about that. And what you could also do is like to limit this kind of updates so they don't happen often. And seriously, the cases where somebody update their email in the system or their name, nobody update the name. The name is like set once when you create an account, and that's it. But if that happens, you can handle the situation and update it in multiple places as well. But at least you guarantee that 99% of other operations like read and write are fast. If this update requires 1% of update that happens rarely did happen, then you just send an update to all places where it should update and you're good.
Thank you.
Now we tend to separate these only under one circumstances, that the data really doesn't fit in 60 megabytes in single document. If that's the case, then you better separate. But other than that, always embed or have the data together. That's general design policy. Any more questions?
Yeah, Professor, can I ask the
Yes.
questions?
Mm-hmm.
Since I don't have that much knowledge of the MongoDB, but from my previous experience of the NoSQL, there is some certain limitation that how many record I can make a query in I mean, how many
It's
record
unlimited. Yeah. It's
I can
unlimited
search in a
size.
single query, and also how much data I can retrieve by single query. Since you're mentioning that if a document can have a maximum 16 megabyte. So that time actually, suppose I have a two record, that is 16 megabyte to 2, it equal to 32 megabytes. So there must be some certain limitation that I cannot retrieve more information. I mean the maximum size of the information, like 25 megabytes of total information I can retrieve with a single query. So there
is no limitation for amount of data that you can exchange when you read and write. So read and write could be just unlimited, and you can save unlimited number of documents as well. The only constraint is a single document. When you write a single document should not exceed the 16 megabyte. Now, if you do have a document, or some data that exceed this size, then you should either change the database write engine, or what you could do is maybe your data are not structured. And in this case, you better use some sort of a file system to save the data in file system and save a reference in your database.
Okay. So
For example, you want to upload a file that's 1 gigabyte. You upload that file to a file system service like S3 or any other service, and you just save here the reference to where this file is located.
I see.
Okay.
So is there any limitation of how many record can I read by a single query?
No.
Like
No, there is no limitation.
Okay. Yeah. Thanks.
Sure. Any other questions?
Hi, Professor.
Hi.
For NoSQL, if we exist the limit of size, because in the big data, if we have millions and records data, so 60 megabyte is cannot enough to store all the data all the time, day by day and year to years. So how we can deal with this scenario?
Imagine that you're designing an SQL database and you are saving inside a single row some data more than 16 megabytes. That would be really bad, right?
Yes.
Now for NoSQL, when they design the database, they guarantee the same performance for documents up to this size. Anything bigger than this size, the storage engine that they are using, which is, I believe it's called Wired Tiger, for data size more than 16 megabyte, it's started to slow down. So if you want to increase the size of your document, then you have to switch your storage engine to a different engine that will guarantee the same kind of performance. It's rarely is going to happen in a real application. I mean, nobody would save a single row as 16 or single document as 16 megabyte. It's a huge size.
So can we use a NoSQL database for a long time running of an application for example 10 or 20 years with the huge document, huge data in some
Yes.
application like banking or insurance something?
On Wednesday, I will talk about scalability, and you will see that since you don't have any limitation in how many documents you can save and why these databases are meant for big data, yes, they are widely used for multi-purpose applications. Now, probably I should also mention that when we don't use SQL, NoSQL, and we really want to use SQL, maybe you don't want to use NoSQL when you need more precise number representation. So if you have a bank and then this bank needs really precise number operations, maybe JavaScript is not the best language, or BSON and JSON aren't going to provide you with this precise number representation. Another reason when you don't want to use SQL is when you when you really tend to have multiple relationships that you created and you need them for some reason, so your design is not optimal for NoSQL, then cases like this, you should switch back to an SQL. And anyway, as I always say, and it is a fact, that there is no application that rely on a single database. You will always have a system that rely on multiple database types, and each type has piece of information that you rely on. So understanding SQL along with NoSQL is essential for developing any kind of application.
Yeah,
But
thank you.
now we're going to focus on how we use the NoSQL and understand its features and master this. I'm sure that you will master the other type of SQL databases in other courses.
Thank you, Professor.
Any questions?
Yeah. So the limitation is 16 MB is the plain text or the vision. So example, when I have a field, so when I insert to the MongoDB, so the plain text limit is 16 MB or is after we convert to vision format.
After we convert to BSON,
After
because the data is saved physically as BSON binary, 0 1s. So that
it means the normally it will be bigger because when we convert to BSON, we will maybe zip the file. So
correct.
yeah, thank you, Professor.
Any other questions? Two more things I want to talk. Yes.
Professor, if you have a few minutes, just I want to make a comment.
Yeah.
Since
Yes.
since in the NoSQL there are a lot of diversion based on their properties and characteristics. So you are just we are learning here just MongoDB. So MongoDB has a specific feature according to CAP theorem. So I think that thing should we consider. I mean, why you have choose MongoDB here? Because
it is the mostly used the most used NoSQL database out there. It has a huge community, and it is the most common option for web applications. That's why. There is no other NoSQL database that's more in use than this one.
okay, but yeah, Professor, thank you.
Sure. Any other questions?
Yeah, Professor, I have another question. So
Yeah.
for the MongoDB, how long MongoDB will allow for the data retention?
Data retention?
Yes.
What does retention mean in Arabic?
Data retention means I have one data. So how long we will keep it on the memory before we move to archive?
I don't understand the concept of retention. I'm not the database expert. Can you explain that to me?
So it means like I have a book, and if I process the book frequently, so I keep this book is active. So if the book is not active, so I will set the data retention, then it's not used. So I set the data retention like after 3 months or 1 year, I will move the book to another location.
Yeah, I'm not sure about if MongoDB has this feature or not. I never heard that it does. It might have it, it might not. So I'm not quite sure about data retention.
Yeah,
But
Professor, I can make a comment.
If you have, yeah, but what I do know is that MongoDB, what you can do in cases like this, to have what we call covered index. So you keep the data in memory. You don't need to access the hard drive again. So you kind of achieve this feature of data retention where you read and write the data fast. That's what I know. Yes, somebody wanted to comment?
Yeah, just you can make a cluster here. So that time you can, based on the logic, and the data will be replicated into the different database. So you can maintain it, yes, for the retention.
Maybe, but cluster or making different copy, I don't think that's what he meant. Retention is like accessing the same data. Oh, I see. Yeah, there is
Yeah,
some
Professor, he
connection.
just want to mention that if any data gets stale, then he want to store in a different location so that his query will be more faster. So that time,
Yeah, so if I see. So another option that we probably we will discuss on Wednesday is that when you send a query, you usually send a read and write queries to one machine or one database. So what you could do in some cases is that you send all write requests to your primary node of your database, and you can create another secondary node that has a real live beat with the primary, so it's kind of live, and you send all the read requests from the secondary. So all the writes to the primary and all reads are from the secondary. That will also probably achieve something to what you asked for. Any other questions? Okay, two last things I want to talk about, and they are features of MongoDB, is that all queries, I can just bring the slide up here and explain them. Yeah, these two things. So we're saying here that all operations, this dynamic schema, support polymorphic type. And all I mean is that if you have a document that has name Asaad and another document that has name is 5 and another one that has age 5. So if I'm performing any kind of operation on collection that has all these different document structure and types, the MongoDB is still, operations are still can be applied, even though with no errors if the documents are from different structure and type. That's what we mean by the dynamic schema support fluent polymorphism. So when you try to read, hey, find me all the documents that the names start with A, probably this document will be selected, this document will be ignored, this document will be ignored. There is no error. Why? Because by default, MongoDB support fluent polymorphism. Another feature that we need to understand properly is that every operation on the document level is atomic. So when you perform read or write or update on a document, you get the state of the document either before the update or after the update is done. So if you're trying to read a document, you will never read half updated document or half inserted document or half deleted document. You either get the document before the update or after the update. That's what we call atomic operation. And it does exist by default on the document level. So no one can read half inserted, half updated, or half deleted documents. Either the document doesn't exist or it is created completely. That's atomicity. Any questions about these two features?
Professor, could you please explain again the the fluent polymorphism?
The polymorphism?
Yeah, fluent polymorphism. Yeah.
Yeah. So as you can see here, I have a collection that has name with document that has name string, another document that has name number, another document that does not have name at all. So if I'm trying to find a document where all the names, okay, is Asaad. A query like this will not fail, even though there are documents that are not string or don't have it. Why is that? Because this is a feature in the database that it supports fluent polymorphism. So the data type can be a word. For example, we see a number. Number will not be converted to string. But if I am searching for a string, sorry, a number, and we found string, MongoDB is going to try to change the type from that string to a number and see if we find that number. So there is data coercion that MongoDB is going to do in order to support this fluent polymorphism, polymorphic type. Polymorphic type means we do data coercion on the type to satisfy all our queries without failing the query. And if the field just cannot do any data coercion, the document will be ignored. We jump to the next document. Oh, it doesn't have name, that's fine. We jump to the next document. So there is no failure whenever you try to do this kind of operations. And this is just because we have dynamic schema. However, when you're designing a web application, you want to maintain certain schema structure and data types. And that's something that we will do at some point later or afternoon. But understand that one of the database features is to support fluent polymorphism. Is it clear now?
Yes, Professor, I got it.
Any questions? I think we're ready to jump into MongoDB and install the database and start using it. So to do that, probably you will go to the website and you have to search for MongoDB community server downloads. Okay. So you have to download the community server. And when you do that, if you're on Windows, you will be greeted with something like this. Just this and download. Now I am on Mac and I see that I also have downloads. I've never tried that, honestly. I'm not sure if this download will really successfully is going to run MongoDB on your machine. You could try it, but if that didn't work for you on a Mac, then you should probably say set up Mac OS. And now we have another link that we need to click on, and then you have to follow these steps to install Brew, tap Brew, install the community server, and then based on your CPU type, whether it's an Intel or M1 or M2, then you have to follow also the instructions how to start the service. If you need some help with that, get in touch with me or just follow the steps and you should be good to go to install MongoDB Community Edition on your Mac. For Windows people, it's super easy, as I mentioned. Just go to community server download, follow the installer and use. In no time, you will have MongoDB installed. Now, once you do that, you should be able to, with MongoDB, you have like a tool, for example, called Compass, which is a UI for the database. Here it is. You just connect to this default connection string, and if everything is correct, you should start seeing all your databases. And here, as you can see, I have a database called Clinic. Inside the Clinic, I have a collection called Reservations, and I have no data in here. Let's say August has Iowa, and I have some documents. So with Compass, you could just browse your database. Let's learn a little bit about how we can perform CRUD operations on a database. Now, for most of the operations that I am going to mention in the slide, starting this slide forward, I'm only going to mention the methods. I'm going to skip the part where you have to pick the database first, and then you have to pick the collection next, and then you call the methods. And the reason is I want to focus on the methods and what do we pass to the methods. And this is the same whether you're using the Mongo shell, whether you're using Express or Node, or whether you're using Mongoose, which is the tool that we will use later in the course, which is going to map every single object to a document. The use of the method is the same, so I'm gonna just keep the method name. So here I'm gonna show you an example. Here, for example, you see, for example, replace one. Update. You cannot call update one. This is not a complete example, but I am skipping the part where I picked db.collection.update one. So in this, most of the slides, you will see me just using operations. Find. There's no method called find. Find only exists on the collection level. So be aware of this fact that I'm using only methods in the slide. If you are in Node, then you have to pick the database, you have to pick the collection, and then you call find. If you are in Mongoose, you have to pick the model name, and then you call find. Find doesn't exist in a global space, just as a note. Because I don't want to keep mentioning the DB collection, or model, and here are all the variations. I'm teaching from method forward. So the first method that we are learning to find documents is a method called find one. And with find one, we are finding the first document that matched the query. Another option that you can pass to find one is projection. And to understand what is projection, every single time you do select, you say select name and age from students, right? So you don't want all the fields of students. You only want name and age. We call this projection. So you say find one document that match this query and only give me the name and age. This called projection. Okay. Let's see some examples. Here's find one. Find me the first document that has a grade 100. Here there's no projection. It will bring the entire document back. Now, similar to find one, we have something called find, which also accept a query and projection, but instead of finding the first document, here we are finding all documents. This is why the results of find in MongoDB is a cursor that you need to convert to array before you read the data. A cursor is just a reference to the data. It's not real data. That's why you will see me always calling to array. Well, if we are using Mongoose, it's different. When you do find, you get immediately the data. You don't get a cursor. So you don't need to worry too much about cursor or array if you're using Mongoose. But know if that you are using the native driver in MongoDB, you don't get the data. You get a cursor, you convert the cursor to array, and then you get the data. So it's like a two-step before you get the data. Let's see some examples to all of that. It is find. Find me all documents that have a grade 100, and then at the end I said to array. Probably you start noticing that all of the functions, the methods that you're calling are asynchronous and they return promise. So you will see me just having await instead of .then, which is much more elegant to read. await these results. When they are ready, assign them to doc, and then process the next line. So this is perfect. Another method that exists called count. And as you can see, count works as an aggregation method. Hey, find me the number of documents that have grade property with the value A. And that will return the number at the end. More examples. In this example, I'm using more variety of API on the collection. So I'm saying find all the documents that have grade 100, but select only the students. So 1 means I need, I want. 0 means I don't want. So in this query, the projection here is that send me only the student name. Don't send me the underscore ID. Don't send me the other fields. And as you can see, I here added skip and sort and limit. So let's say I got 100 results. Skip is going to skip the first 10. So the first 10 will be skipped. Sort is going to sort these results in ascending order. So 1 means ascending, -1 means descending. And limit to 10, so I'm going to pick the next 10. Now for the skip and sort limit, they are always triggered in the same order. So the results will be first sorted. Next, it will be skipped. And the third operation is always going to be limit. Always in this order. These are just instructions to the cursor. And as you can see at the end, I said to array. If you are using Mongoose, you don't need to array. Any questions about this find query?
I have a question, Professor.
Yes. Yes.
So I see that every insert or something delete like that, you use await. So it means that the outside we need to declare the async before using
Yes,
the await.
Oh. Yeah. So because I'm going to do all of these operations inside request handler, so you will see me doing async, request, response, next, and then I have this code. So I always mark the request handler with async in order to use all the awaits inside, which will make your code much more readable.
Okay, thank you.
Any other questions?
Professor,
Yes.
I question about the projection. So for example, we have a table and it has 10 fields.
We have a document, yes.
Yeah, we just have one field, so we have to mark all orders or 0.
No, the projection work is you either set 1, 1, 1, 1, or you set 0, 0, 0, 0. You can't mix 0 and 1. The only exception to this rule is underscore ID. Okay, this is why I have underscore ID 0. But if you don't want to hide, because underscore ID will always be part of the results, so you can turn it off. But when I say student 1, it only means that send me students. Don't send me the others properties. And if I said student 0, it means send me all the other fields except for student. So you don't need to do that for every single field, because the rules is either use ones or use zeros. You can't mix them. Exception is underscore ID that you can always turn it on and off. You don't need to turn it on because it will always be returned, but you can turn it off in one projection.
Yep, got it. Thank you.
Good. Any other questions? Okay. So insert one is just like insert query in SQL. You just pass an object that will be added. And insert many accepts an array of multiple objects. All of these objects will be dumped inside the collection. We have also delete one and delete many, and that accept a query. So when you say delete many, year 2022, all documents that have year 2022 will be removed. If you say delete one, year 2022, the first document that have year 2022 will be removed. So this is how you add also or remove documents from a collection. Let's see how we update documents. To replace the content of documents, for example, for a put request, you probably want to use replace one, because replace is going to replace everything in the document with the new content. What's that? Oh, sorry, I removed the wrong part. So replace is going to remove all the data in the document and keep the new data in. It's going to replace the entire document with the new data. While update requires some sort of operators that you want to control. What do you want to change? What do you want to patch? So these are ideal for patch requests. So as you can see here, I'm using an operator called set. Here I'm using an operator called increment. Here I'm using an operator called unset. So set operator is going to patch certain field. Inc is going to increment. And unset is going to remove the property. So when I say I have this document and I say patch students to become 500, students will be patched value from 250 to 500. Courses will remain the same, no change. And then I'm saying set entry to August. Now the document doesn't have entry, so it will add the entry property and add it with the value August to the document. So as you can see, set is just to patch certain fields in the document. Increment, you basically use it to increment or decrement. If you have a positive value, it will be added. If you have a negative value, it will be decrement. So if I say increment students -2, what's going to happen? The students will become 248. Increment exams by 1. Exams doesn't exist. It will be created and 1 will be added. Unset, simply remove the property. So if I have this document and I said unset program will be removed. I just have students remains. And the value here that you pass here to unset doesn't matter. You can just pass 0, 1, true, false, whatever. We just need to maintain correct JSON structure. That's why I passed 1. But the value doesn't matter actually. So that's how we replace or update for put and patch requests documents in the database. Any questions?
Professor, I have a question.
Yes, thank you. Yes.
So for the set and unset, so after we do these two commands, so the data will be inconsistency. Example, I have 2 rows. Then the row 1 I set, then I increase 1 more field. Then when we query the data, this field is not available. Example, when I run the unset program 1, then the program field is not appear anymore. So in this case, the data will be not consistency.
No, the data will remain consistency because of atomicity. You remember? All of these operations are atomic. So previously you didn't have program. Next time previously you did have program. Next you didn't have program. Queries, because of polymorphic type of queries, they will not fail. So this is all fine. It's good. Now I understand that, oh, now I have this property now. While this is okay, this is a behavior that you don't desire in your application. So you will rarely This is really rare to use. We mostly use set and increment a lot, but not to add a new property. Adding new property also very rare in this case. And this is why we perform most of these operations how? Using Mongoose. And Mongoose has very strict constraints about the structure and data types of our data. You just need to know that these operations outside of Mongoose are fine. MongoDB doesn't mind. It's a schemaless.
Professor.
So any
Professor?
other questions? Yes.
Can we use the increment for the string, or just only for the like integer?
Can we use the increment for what?
For string.
I didn't understand the word you're
The
using.
string.
For?
For example, like if the student name, we have to remove the first name, something like that. I got a string.
You want to use increment to remove first name?
Yeah, that's right.
If you want to remove property, you have to use nset.
No. Like I have the full name, right?
Yes.
And I have to remove the first name.
So you want to remove Asaad and you keep Saad?
Yeah.
Then you have to use set. You have to use set to parse full name from Asaad Saad to become full name just Saad. So you have to use set.
So it just
That is going to patch fields from
it's
value
like
to another value.
the specific situation. I want to be like dynamic.
Was that a question or I didn't get what you want?
Okay, maybe.
Did I answer the question or still? Yeah.
Yeah, maybe I can like have a conversation later. It's okay.
No, it's okay. Just
yeah. For example, like a student have like a grade, right? Grade we have like 9. We want to like use increment to increase the grade by 1 is to 10, right?
Yes.
And
yeah, in cases whenever you need to increment or decrement numbers, use this operator in order to just patch a value that's not number. You could use set, and that would just replace the value.
Okay.
And all of this operation, don't have access to the previous value. So you should know the previous value in order to make the change. Yes.
So in the case of Mongoose, will it give our collection some sort of structure? If we apply Mongoose?
Yes. So in the first step in Mongoose is to define schema. So we have a structure and we have data types. So operations like this one would be like really not something. Oh, if the schema has it, then it's fine.
Yeah, only if the schema has it. If it doesn't, so we cannot just add
if it doesn't, then you cannot like add just random property, no.
Okay.
But you could remove and add the properties if the schema has them.
We can remove. Okay.
You can remove because you can create a document, and but in Mongoose you can also have required properties. So these properties are required. Other properties are optional. So that's why sometimes some properties don't exist, which is okay. You don't need them for all documents. So we will get to these scenarios when we use Mongoose.
Thank you.
Sure. Any other questions? Before we go to a break, I want you to know one last information, which is all of these many operations, like when you remove many or when you update many, you might think, oh, this is expensive. It's not expensive. MongoDB, while you could lock the entire collection with certain operator, MongoDB is going to operate this operations in batches. So it does the first batch of update, and then it yields to other operations to start reading or writing or insertion. And then the other operations also yield back to the update to update the next batch. And then this batch will be paused to yield to other operations, come and read and write. As you can see, probably this, if this is something okay with you, then you should be fine with it. If that's not, you could also isolate the entire collection to perform this. And yeah, that's basically how batch operations work. They work in batches and they yield to other operations to come and perform on the same collection. That's by default, unless you explicitly isolate this collection to lock it, to have to finish the entire process of this collection before you unlock and allow other operations to perform. Any questions? And this is probably explained somewhere in the slides as well, I believe. Yeah. Good. Let's take 10 minutes break, and after the break, we are going to learn how we operate on arrays, basically. Welcome back, everyone. We kind of learned before the break how MongoDB works, an idea of what schemaless means, and we learned how we do CRUD operations or meals. If you remember, a meal represents document inside that virtual array that we created. So in order to add a meal, we just say insert one. In order to find meal, we can just say find and we pass a query. And if you want to update a meal, we can say update one and then pass the meal ID and update that specific meal. So manipulating first level documents is easy using the methods. Now, sometimes when you are doing find queries, you don't want to pass one precise value. You want to use some operators like greater than equal, lower than equal, not equal, in, not in, and probably you just want to use comma to do certain action, and comma represent basically AND operator. So let's see examples of some of these operators that you want to use when you've tried within your query. In the first example here, I'm using greater than. So I'm saying find me all documents that have score property. The value should be more than 85. So it is AC6 or more. If this condition match in a document, the document will be part of the results. The second query, I'm saying find me all the documents that have quantity property. And here I'm using in operator, and in operator used for implicit or. So all I'm saying, find me all the documents where the quantity field has a value of 5 or 15. To do that in MongoDB, we use the in operator. So in operators works as implicit or. The last query, I use the comma. And comma works as implicit and. So all I'm saying here, find me all the documents. Every document should have a score with value less than 85 and the quantity is 5. So the comma represents an implicit and. So this is general how we use implicit and, implicit or, and any of the greater than, lower than operators when we find queries in collections. We do also have an explicit and an or. So when do we use the implicit ones? And when do we use the explicit ones? We use the implicit ones if we want to perform the or the and on the same field. And we use the explicit one if you want to perform them on different fields. Now, can I use the explicit on the same field? Yes, you could, but it will be slower. So it's recommended by MongoDB team that use the implicit form when you perform it on the same field and the explicit form when you use them on the different fields. So here we see an example where I use the explicit or. So I started with or, and I have an array here that has 2 elements. So this query reads as, find me all the documents where quantity is lower than 20 or price is 10. So we have 2 conditions separated with or inside the or array, basically. Now, if you can I do here quantity less than 20 and quantity something or quantity something? You could, but that's going to be slower than using find quantity and then you use in operator with multiple values. Any questions about implicit form and explicit form? Now, the next thing that we are going to step into is working with rich documents. And all I mean by rich documents is complex documents, documents that have array of values or array of objects, and every object that have multiple values. So every single time you have complex document, we call it rich document. An example of a rich document is what we worked with last week, which is the example of meals and ingredients. So the meals document has an ingredients property that it has an array of multiple ingredients. Meals is the document, and inside this document we have array of ingredients. So we call this document rich. And I call ingredients first level array. Because inside the meal, I have first level property called ingredient, which represent an array of objects. So I call it first level. If every one of the ingredients has also another array, then it's second level arrays. So we will learn how we manipulate basically now arrays. How can I search for a single ingredient? How can I update an ingredient? How can I insert an ingredient or remove an ingredient? That's now what we're going to learn next. We already learned how we insert a meal, update a meal, or find a meal. We used insert one. We used find one. We use remove one, remove many. But now how do I control ingredients? So we're going to search an array, update an array, remove from an array. This is what we're going to learn next. So the first thing that we're learning is how to search for a certain ingredient or search an array. Well, in MongoDB, you can simply pass the value. Even if ingredients or courses here is an array, MongoDB will scan every single one of them. If it finds the value, it will return the document. So there is no special syntax when you try to find an array, a value inside an array. You just pass the value, which is nice. We could also use some operators to search for more than one value inside. So find me a recipe that has ingredients olive oil and black pepper. Or find me a recipe that has olive oil or black oil. I don't know if this black oil, it's oil. Anyway, you got the idea. So how do I do or and in this case scenario? We use in and all. In is the same meaning as if it was for non-array fields. So I'm saying find me a document that have courses and the value of course, look at course is an array. It's either 571 or 571. So in still works as implicit or. To perform an AND operator on array, you will use an operator called all. So here find me only the ingredients or courses that have both of these values. So if both of these values exist, the document will be returned as part of the results. So searching an array field cannot be easier. Just mention the values, use some operators that you probably need, and you're good. Another way to search the array is by using an operator called element match. So when do we use element match? And when do we use just the value? So when searching for a single value, you don't need element match. I use element match when I search for more than one condition and the condition require operators. If I need to search for more than one condition, I can use in, I can use all, I can just place the values. I don't need element match. But I use element match if I'm searching for more than one value, for more than one condition, and the condition requires operators. For example, I need to find an item inside this array that is between 6 and 9. That's condition. You can't try it in using in or all or any other form. Why? Because you're searching based on two conditions, and both of them, they use operators like greater than and lower than. When you have such complex conditions, you use element match. Can I use element match to search for single value or value that doesn't have operators? Yes, you can. That's fine. But most of the cases we use it for more complex conditions like this one. So element match, all it means is find inside results array. So results in this case should be an array. Element match only works on arrays. So this query says, search this array for one element that match this condition. And the condition, as you can see, is greater than 5 and lower than 10. So it's a single element that's between 6 and 9. So we have 3 documents and we are running find. Find will go over all 3 of them. The first document, 6 and 9, no, 6 and 9, no, 6 and 9, no, 6 and 9, no. The first document is not part of the results. Second document, 6 and 9, no, 6 and 9, yes. The document will be part of the results. Third document, nope, the third document is not part of the results. So what is returned from this query is the second document. Now the question is why? Why the second document is returned? Because there is one element inside this array that matches this condition. Which one? The one with index 1. 0, 1, 2, 3. Right? So why this second document was returned as the result of this query? Because the element and index 1 match this condition that I passed to element match. Is there any other condition that match? Yes, there is 9. 9 also is between 6 and 9. But this element with index 2 is not the reason why the document was selected. The reason why the document is selected because of the first one that match. Right? So just keep that in mind because MongoDB later will give you a reference to this element that really matched the query. And we will use that reference in order to do some actions. So every single time you search an array, the element that is the reason to have the array match the query and be part of the results, we always get a reference to it. And this reference is basically a variable called $. We will use that in the upcoming slides. Any questions about element match? Good. Let's see how we can take more examples. Now we learned how we do find ingredients. Finding ingredients is easy. How do I find a value inside the array? We just pass the values of the array inside a query. But how can I update an ingredient, remove an ingredient, or add an ingredient? Here is how you update one. Here is how you add one. Here is how you remove one. Remember, we are working with first level arrays here. In order to update an item inside an array, you need the index of that element. So if you have an array that has 0, 1, 2, 3, 1, 2, 3, 4 values, and you want to update the third one, you say a.index, make it 5. So the element with index 2 will become 5. That's how we update an element inside. So in order to update an ingredient, basically, you need the index of this element. And we can grab the index from the find query as I explained earlier. We will see that in upcoming examples. How do you add a new ingredient? We use an operator called push to push an element to the array. So if you have an array with 1, 2, 5, 4, and you push to A the value 6, 6 will be added at the end. If you use pull and your array is 2, 5, 4, you basically remove 5 from the array, and now your array doesn't have 5. So in order to add or remove items from an array, we use push and we use pull. So that's how we do full CRUD operations with arrays. Find is easy. To update, I need the index, and to push and pull, meaning I'm adding a new item or removing a new item. But did you take a look at the method that I'm using here? For all of them, I'm using update. Why? I'm updating the meal, or I'm updating the document that has an array of ingredients. So all you're doing basically is just updating the document to manipulate the array, which is A in this case, or ingredient in our previous example. That's why all of the operations are update. I'm updating the document to either update an ingredient or remove an ingredient or add a new ingredient, which is manipulation for arrays. Now let's take a look at other operators that you can use. There is also pop. Pop is going to remove from the right side, and pop -1 is going to remove from the left side. So pop with positive value, pop 1 is going to remove 6. Pop -1 is going to remove the 1. Either you remove from the right side, which is the default, or you remove from the beginning of the array if the value is -1. Now we have another operator that's very similar to push called add to set. Push, as you remember, it adds the value at the end. But add to set, it adds the value only if it doesn't exist. So it treats the array as sets. So there are no duplicates inside the array. So that's another two helpful operators you can use on an array. Any questions? If there is anything more important than this slide, I don't think there are any one. This is the most important slide. You need to understand how to manipulate an array, because this is like exists in every single application. You have a rich document that you need to control arrays within. How to add document, remove document is easy, but how can I update an array in document? Remove item inside an array in a document. These operations require some understanding to these concepts. Questions? Good. Let's see. The rest of the lecture is just a few examples to master basically these skills. Let's see the first example. The first example, I have a document and I say, update this document, change the grades, some $, 82. Let's forget about the update part. Let's focus on the query. I have a query that says, find me one document that has ID 1 and grades 80. Okay, MongoDB will find a document with ID 1, and now it will scan the array for value 80. 80? No. 80? Yes. The document is selected for the updates. Do I have any other 80? Yes. But which one was the reason the document is selected for update? Is this one that has index of 1, 0, 1, 2, 3. Now, as I told you, every single time you're searching for an item inside array, MongoDB gives you a reference to the item index that matched the query, the first one that matched the query. And this index is basically the $. So when you say update grades.$82, all you're saying is update grades.1 82. So it's going to update this item to 82. Note how the other 80 remain the same. So with the $, with the index, you just update one item only. Same thing with this different example. I have a document and I have an update. Find me a document that has index 4, here it is, and grades.total 85. Is grade.total 85? No. Is total 85? Yes. MongoDB will take this document for updates. Which item inside this array match? This one. So $, here in this case is also 1. So all you're saying here, set grades.1.student 6. So grades.1.student, you make it 6. That's basically how it works. Questions?
But if I want to update, like, for example, like all the students like that have like the grades of 85.
Next slide.
Next slide. Okay.
And basically the one is this one. But first, let's see how we update one only. I have a document, update 1. Find me a document that has ID 5. The grades is one element that match this condition. Why I use element match? As you can see, I have multiple conditions with multiple operators. So I have to use element match. So my element should be, has a total of, with a total lower than 90. So 90 or less. The mean is going to be 81 plus. Okay, let's search the first element. Less than 90, yes. And the mean is 81, no. Second, less than 90, yes. The mean is 81, yes. So this one match. This one match. So $, in this case will be 1. So what I'm saying is patch grades.1.student, make it 6. Grades.1.student, this value will become 6. However, if we scan further, we see 90 or less, and I see something more than 81. But this item was not updated. Here I'm updating using the $, which refer to one indexed item. How can I update both of them? To update more than one element that match some conditions, we use a technique called array filters. Let's see how update filters work. I'm going to explain it to you in details. So as you can see, first, I removed all my conditions from the query. I no longer have any conditions in the query. I kept my query, just find me a document that has ID 5. And I predefined here a third element inside update. So update has three parts now. The query, comma, whatever you want to update, second, and the third element that you can pass to update is options. Options object. And inside this third object options, I pass something called array filters. And array filters, what you do is you pass predefined conditions. And you choose the name of the condition. I defined a condition called obj, like an object. You can name it potato, you can name it student, you can name it anything you want. I called it objects. So I said, inside this array, I defined single condition. So the object.total should be lower than 90, and .mean should be less or equal, less than 80. So now I'm going to use the object filter name and apply this name on the grades. How do I apply a filter by name on an array? You do that by using the $sign. We have an array here. $, square bracket, and then filter name. What happens is the filter will be applied on the array. That's how the syntax works. So now that I defined a filter called obj, I apply this filter on the grades array. Now let's apply this filter on the array. So I'm doing with this document with ID 5 is the following. Hey, patch grades dot filter the grades by this condition. When you filter the grades by this condition, this doesn't match the condition, and both of these do match the condition. So now what you're doing is you're changing the left of the documents dot student with 6. So this value will be 6 and this value will be 6. So that's how we update more than one element inside the array. We need to filter the array to keep the elements that match the condition, and all of them will be updated. That's it for today. Let's just see more examples. Another example. Update all the documents. Empty query, it means update all documents inside the collection. Now I defined here I predefined two filters. I have here an array that has one filter called T and another filter I call score. T basically is an object.type is quiz. The score will be 8 or more. Okay, here we just predefine some options. Here is the query. Update all the documents. Increment the following. Hey, filter the grades by T. If I am going to apply this T condition on the grades, this will be filtered out and this will be filtered out. Why? Because the type is not quiz. I need the type to be quiz. Next, dot questions, filter the questions with a score filter. The score is 8 or more. So if I want to filter the questions, remain, filtered out. Remain, filtered out. What I'm doing with this value, I'm increment by 2. 12, 10, 10, and 11. That's basically how we use array filters. We just apply the filter by name on the field. All the values that remain will be updated. More examples.
Professor,
Yes,
sorry, can you go back to the previous slide?
yes.
How did we come up with the index score? Like,
Can
is
you
it
repeat the
just
question,
is it
please?
just something that we gave score? Yeah.
Oh, yeah. So when you define a filter here, you have to pick the name, any name. You can call it T, you can call it Ray2, you can call it anything. I can call this one Saad, doesn't matter. The name is just the name. But here you have to pass Ray2, here you have to pass Asaad. It's just a name. I'm saying apply this filter name on questions. The filter says that the value should be 8 or more. So I filter out all the values that are not 8 or more.
Okay.
Yeah. Any other questions? Let's see some more examples. In this query, I'm saying update this query. This is update. The query is find me a document that have grades, and this array should have one element that is greater than 10, so it's 11, and lower than 30, so it is basically to 29. 1129? Nope. 1129? Yes. This document will be updated. And what we do with it is set grades dot whatever match, in this case 1, make it 15. So this one will become 15. Second document has the same data. So it will also, this one will match, and we will make this one 15. So with the $sign, we update one element that match the criteria, the query. How can I update all the elements that match this condition? We need array filters, right? Let's apply this to update both 20s to become different value. Okay. Now inside array filters, I created one filter called C. C is just the filter name. I'm saying this filter name is a value that is between 11 and 29. Other values will be filtered out. So what I'm doing with this query is I'm changing filter all the grades by this filter. When you filter, you get rid of the 10, you get rid of the 10. All the other values, you set them to 30. So this becomes 30, 30, 30, and 30. All the values that are left are filtered, are changed, set. So that's how we use array filters to update more than element inside the array that match the condition. Any questions? Now with all of these operators, you probably are ready to convert last week RESTful code example about the meals and ingredients to use MongoDB and perform all these operations to manipulate the meals and the ingredients. You should be able to do that, and that's basically your work in the afternoon. But before I show you some code and maybe how to use Mongoose and stuff, let's learn something about index, a feature that you probably need to use when you wanna have extensive search in your database. So what is an index? Index is simple. So basically your data lives inside the database, right? Here you probably have a collection. Inside the collection you have documents. But let's say inside this collection you have 1 million documents. And your document is find where the name is Asaad. Now it probably is guessing. A query like this require scanning all million records. And this record, they exist on the hard drive. That's really bad, isn't it? Scanning 1 million documents on the hard drive to find all of them that has Saad. That's bad. So a common technique that we use in databases is a concept called index. So in this case, if I'm always searching by name, what I can do is I create an index on name and sort the index ascending order. Index are always sorted. And indexes always live in memory, not on the hard drive. So the data structure for an index is basically some sort of a B-tree data structure. However, let's think of it just for the purpose of understanding indexes, that now I have an index that has Asaad, then Mike, and then Theo. And the right part of the index is references to all the documents that have Asaad, and all the documents that have Mike, and all the documents that have Theo. Now, when you search, find me all the documents that have Asaad, you don't need to scan 1 million documents on the hard drive. MongoDB will go to the index because there is index on the name property. Since it's sorted, immediately has the references to the real documents, and you accomplish this query inside of time complexity of n. You now accomplish the time complexity of login. And if you don't understand time complexity, take the algorithms course. But anybody who did, you understand that login is fast and n is very, very slow. So all I mean here by n and login is that this one is very slow because it requires scanning n documents. This one is login, which is very fast. It's only going to fetch the references immediately from the index. So we perform now all the operations faster. That's the concept of index. They live in memory, they're always sorted, and it will help you find documents fast. Now, one type of indexes that's very useful in MongoDB is geospatial index. And the geospatial index will allow you to find the nearest points based on a current point. So if you have a map and you are here, and every single point also has locations, what you could do is to find the nearest points that match certain criteria, to find your nearest friends, nearest restaurants, nearest services, etc. Now, how is that possible in MongoDB? You create an index called 2D. So if your document, for example, has a field called location and has longitude and latitude values, if I create an index on the location field and I pass the type as 2D, note here that there are two different geospatial indexes in MongoDB. One is called 2D and one is called 2D sphere. And here I'm talking about 2D. This is the one that we will be using in the course. So if you check the documentation, don't get confused. Okay, we're using the 2D one. After you create an index on this field, now you can use the near operation inside the query to find the nearest points based on your current location points. Now, also part of the practice in the afternoon is to do something like this in a collection. If you do have time, finish that. If you don't, we will work on it together during the coding session tomorrow, Tuesday. But that's the concept of indexes and geospatial indexes. Any questions?
Professor?
Yes.
The index it will store in the memory, so it's in the memory when we start the Mongo database or we start the applications.
Yes, when you start the instance, they are refreshed in memory. Now, if memory doesn't fit anymore, then you will be using the hard drive as memory, and that's bad. So make sure your index fits in memory.
But when we start the application, maybe at the time we still doesn't use the MongoDB.
Yeah, MongoDB when you shut down MongoDB, it will persist that somewhere, probably in a file. When you start the instance again, it will be refreshed back from the hard drive. And every single time you make changes to your database, insert, update, or delete, the index is automatically refreshed.
Okay, thank you.
You're welcome. Any other questions? Now let's see how could we use Mongoose to perform everything we talked about, all this find and stuff. And the first step is to install Mongoose in your application as a third-party dependency. The next thing is you need to import Mongoose, and remember, we're not using require anymore, so you have to import Mongoose from using ESM modules. The next step is you connect to your database instance. And we do that by using MongoDB. Usually the instance that you create doesn't have username and password, so use 127.0.0.1. The port is always 270.17, and then you pick a database name. Let's call it tests. That's how we create a connection to the database. Next, you need to create a schema. As you can see, the schema has a precise structure, and every single property is typed. And you say whether it has an index, whether it's unique, whether it's required. You precisely describe every single property. So that's good. And you have a variety here of data types you can pick. The last step is to convert the schema to what we call a model. And every instance of this model represents one document. Now here, as you can see from this file, I have a model called user. Now, after you create your model, it's super easy that you create new documents by creating a new instance of the model, and then you call save. And how do I find or update or delete? You use all the API that you used first, but this time you use it on the model name instead of db.collection. So the model by itself represents a reference to the collection. Now, check also Mongoose API because it comes with a variety of different APIs like find by ID, find by update by ID, update by update and find and update. There is a lot of combination of methods that are way beyond just MongoDB. But in the background, they use just MongoDB plain native driver. However, I encourage all of you to use basically Mongoose because, as I mean, forget about the easy syntax here. There is simple reason enough that you are defining schema with precise structure and types, and this is something you need for your application. So that's basically the general guidelines on using Mongoose. So hey, I have the last week, that's your homework. If you check the homework, it will say that, hey, update the code to start using Mongoose. That's homework, okay? Now, do I have here node modules? No. Okay, let me install node modules. Good. The first step is to start working on this, is to install Mongoose. And the next step is the mrun start is basically connecting to my database. How do I do that? From app, let's import Mongoose. And I need to connect to the database, and I do it with the init phase. Remember the steps. In the init phase, I'm gonna initialize the connection. So I can say mongoose.connect, and then I pass the connection string. And the connection string is basically, it's going to be MongoDB protocol 127.0.0.1, the port to 7017. And let me pick a database name. I'm going to call it March because we are, oh, it's April. Now, just to know that I did everything correctly, I can have .then and .catch and then print some message. But I need to use async await because they're just nicer. So what I can do here is to create a function that calls itself. And then within this connection, I can add a try catch. And inside the try, I can connect. And I can wait for this connection. And if all is good, I can console.log connected successfully to April DB. And otherwise, you can just console.log error connecting to DB, and then I print the error. So this is just to confirm that I do have a connection. If I check now the things, cached E doesn't exist. Oh, I put the console log outside the cache by mistake. As you can see, successfully I connected to the April DB. Now I'm ready to define a model and use it. So how do I define a model? I'm just gonna create inside models folder a model that I'm gonna call a user model. I need Mongoose instance, so import Mongoose from Mongoose. The next I need to create schema, so const user schema is mongoose dot schema. And I say, for example, every user will have a full name, the string. It should have an email, that's string. Yeah, and role, which is a number, for example. And I can say automatically add timestamp true. Just to add created by and updated ads. So automatically Mongoose will add these. Now that I have schema for my user collection, I can convert it to a model. So I can say const user. Basically, I don't need const user. I can export the model immediately. So I can say here mongoose dot model, and I create a model called user, and here I could simply pass the user schema. So that's a model that I need to export. So I can say export default mongoose.model. Now that I have a model called user, I can use it in my application. Let's use this to create some user. So I'm gonna here create hard-coded route called /users. And here I can say async request response. Next. Don't forget try and catch. And inside catch, I can call next. Now, how do I add a new user? I need to send a post request to /users. Inside the post request, I need to read the body. So the new user would be the request.body. How do I insert this user inside the database? I need to use the model. So here I can say user model. Was it imported? Yes, here it is from the correct place. Nice. I say user model dot create, and I pass the new user. This is asynchronous, so I'm gonna wait for it. And then I'm going to read the result. And when it's done, I'm going to respond to JSON, the result. That's basically how we can use Mongoose and use the model to add, edit, delete documents. Let's test this code and see if it's gonna work. I'm going to create a test file. So users test.http, and let's say if I send post request to HTTP, what's my port? 3000. Okay, good. HTTP localhost 3000/users. Let's pass content type as JSON and pass a new user. And my user should have 3 properties. But actually, none of them is required. If I need one of them to be required, then I pass an object and I say the type is string and required is true. That's basically how you make something completely required. So back to my test. So here I can pass this object. So full name is Asaad, and email is asaad@miu.edu. Let's test this code, whether it's going to work or not. Successfully connected. I'm going to send this request. And I did receive results that a document was created Here I see the underscore ID automatically generated for me. I see created ad and updated ad because I added the timestamps. And if you want to inspect the database using Compass, I should see now a database called April. Here it is. Here's my users collection, and I see my user was successfully added as a document. So that's how easy we can use Mongoose. Any questions? You generate the schema, you convert the schema to a model, and you just use the model in your application.
Professor, can you go back to
Yes.
the test?
To the
test?
Test? Yes.
The test was.
Yeah.
What's the value underscore v? I saw another value.
That's automatically, yeah. That's automatically generated by Mongoose to keep track of the version of the document. This is something added by Mongoose. And I believe there are flags that you can pass to filter that out and or not created. You could customize Mongoose for that. But it's a Mongoose thing, not MongoDB.
Okay, thank you.
Sure. Any other questions? Good. Let's meditate and we go to lunch. After the break, I want you really to take today's homework very, very seriously. Start by converting the meals and ingredients to Mongoose. Create schema for this structure. You need one schema which has meals, and inside the meals we have complex array of complex objects. And then start working on your queries one by one. We already have the structure, we already have everything we created last week. Now it's time to update this, not use this model. We're going to use the new model that you created and update the meals and ingredients accordingly. And tomorrow in the coding session, we will go over all of these, code them together, explain every single route and query together, add extra as well. And we will also work on the extra requirement that you can find also in the homework for working with the geospatial query. I'm pretty sure that only a few of you might be able to finish that. But if you did, it's nice to work on it. If not, that's okay. We will finish it together tomorrow morning. But the main thing that I wanted to work on is making the updates for the meals and ingredients from last week. The extra requirements can wait until tomorrow. We will work on it together and code that if you don't have time. Any questions?
Yes, Professor.
Yes.
I have another question regarding to the index. Can I say this when we start the application, when we connect to database, the node will assign it to the file system IO, and at the time when application start the